This video is for Chapter 6, Part 11. It covers additional information on global variables, and it discusses static and automatic variables. Let's start with the global variables. Other notes about global variables. There are a few things you need to know about global variables. You might think it's easier to just make all variables global. However, you face certain problems if you do this. For example, sometimes things go wrong when you are writing your programs. And it can be very difficult to find the problem if several functions are using the same variable. That complicates things, and sometimes it complicates it quite a bit. So now let's take a look at the slide for more details. The first bullet point, some compilers initialize global variables to default values. Not all, but some compilers initialize the variables to default values. For example, int, double, and float would be initialized to 0, but you need to be sure if your compiler does this before you rely on it. Next, the scope resolution operator is created with 2 colons. It is used to allow a global variable that is declared before the definition of a function to be accessed by the function even if the function has an identifier with the same name as the variable. For example, by using scope resolution operator, the function main can refer to the global variable z as : z. Last, C++ provides a way to access a global variable declared after the definition of a function. However, the function must not contain any identifier with the same name as that global variable. As stated earlier, using global variables can cause side effects. A function that uses global variables is not independent. So if you want your function to be independent, you don't need to use global variables. If more than one function uses the same global variable, it can be difficult to debug programs with the code, and problems caused in one area of the program may appear to be from another area. That's what makes it so difficult. Global named constants have no side effects. Here's an example of a constant. You use the reserved word const, const for constant, then you define or declare your variable. These have no side effects, so these would be okay. Automatic variable. This is a variable that the memory location is allocated at the block entry and deallocated at the block exit. In other words, the function, when you enter the function and when you exit the function. So when you enter the function, the variable memory is allocated and it gets to use that memory, but when the function is exited, then that memory is no longer available. It's let go of, okay? A static variable, the memory remains allocated as long as the program executes. So this one is based on the function, right? And this one is based on the program. Global variables declared outside of any block are static variables, okay? And I suggest you watch tutorial video number 8, and it gives you a little more details on this. You can declare a static variable within a block by using the reserved word static. And the syntax to declare a static variable is the word static, the data type, like integer, double, float, and then the identifier, the actual variable name. Static variables declared within a block are local to the block. So if you declare a static variable inside the function, then it is only going to work inside that function. Have the same scope as any other local identifier in the block. So anything that's identified inside that function is only useful inside that function. We just completed part 11 of chapter 6. In the next video, part 12, you'll learn about debugging tricks, function overloading, and functions with default parameters. See you there.